Figures 16.8 through 16.10, auto pointer object manages dynamically allocated memory. In the last two examples, we were showing you what happens when new fails to allocate memory because there's not enough memory available. Now, one of the key reasons that that occurs in C++ is because the programmer that allocated the memory didn't properly deallocate the memory when it was no longer used. So typically when you allocate dynamic memory, you allocate it and you assign it to a pointer. When that pointer gets removed from memory or goes out of scope, it doesn't automatically take with it the dynamic memory that it points to. So in the C++ standard library, they've created a somewhat smarter pointer concept called an auto PTR, auto pointer, and it's basically a class that works like a pointer. An object of the class works like a pointer. It gives you the ability to interact with data like a pointer, but when an auto pointer goes out of scope, it automatically takes with it the dynamic memory that was allocated in the first place. And this is a concept that we call a smart pointer. Now, there's lots more robust concepts in terms of smart pointers that are implemented as part of the Boost C++ libraries from boost.org, and several of those will actually be included in the future new version of the C++ standard, which is due around 2012. Here we're going to take a look only at the auto pointer class that's built into the C++ standard library's memory header file and show you the basic syntax of it and how to use it. And then if you're interested in this concept, you should certainly take a look at the Boost libraries in more detail at their various smart pointer classes. Now, before we get into the main part of this program, let's take a look at a class that we're going to be manipulating in the example. We've created a class called integer, which encapsulates the primitive concept of an integer. We have an int variable called value as the private data. And for pedagogic purposes in this example, we have a constructor and a destructor. The constructor can initialize an integer to 0 by default, and it will also print out that the constructor was called so you can see when it happens. The destructor will show you when the destructor got called by printing that out, just so you can see that indeed the memory being managed is being deallocated properly, because the destructor, of course, gets called only when the memory for an object is deallocated. And then we have set and get integer functions that allow us to modify the data in an integer object and get the data from an integer object, respectively. So our implementation for this class is pretty straightforward. We have our constructor that initializes the value to whatever is passed in and prints out that it was called for pedagogic purposes. We have our destructor that prints out that it was called for pedagogic purposes, and in both cases I include the value stored in the integer object so we know which one was being manipulated. And then we have our simple set and get member functions as well. So now let's take a look at how to use auto pointer with a simple example here in main. First, we print out in this example that we're creating an auto pointer object that points to an integer. An auto pointer is a class template, so you'll notice here when we say that we're going to create an auto pointer object, we have to say what type of data it's going to point to. In this case, an integer object is what it's going to point to. We named our variable PTR to integer, indicating that it points to an integer object. And the way you initialize an auto pointer is with whatever is returned from the new operator. In this case, we want to create a new integer and initialize it with the value 7. Remember that new will return a pointer of type integer in this example, and that is what will be stored in this object. So once we initialize the object, that is the auto pointer, I should say, it's now pointing to the integer object that contains the value 7. And to prove that the integer object did get created, let me just run the program so we can look at the beginning of the output, and you can see that we were creating an auto pointer object that points to an integer, and we see the constructor for the integer 7 got called. Now, a key aspect of an auto pointer is that it has the semantics of a regular pointer, which means you can use the arrow operator to interact with the object that it points to. So pointer to integer, arrow set integer says go to that integer object and call its set integer member function and set the integer to 99. Similarly, we can use the dot operator with the dereferenced pointer as well. So just like a regular pointer, you can dereference an auto pointer, which moves you, if you will, conceptually from the pointer over to the object, and then you can use the dot operator on that so that you can access the getInteger, in this case member function, which returns the value that's currently stored in the object. And if I stop there for a moment, you can see that we are manipulating the integer, and after we called setInteger, the value is now 99. Then we hit the end of main. Now when the end of main is reached, any local variables, in particular ptr to integer, get deallocated or destroyed, and their destructors get called. Now, because of the fact that we dynamically allocated memory in this example, we want to make sure that the memory gets deallocated. And when the destructor gets called on an auto pointer object, it automatically deletes the dynamic memory that it was managing. And to prove to you that it automatically deletes that memory, remember that we set up the integer class to display some information when its destructor gets called. Now normally dynamic memory, if you don't explicitly say delete, is not going to be returned to the system unless the program terminates. And if I were to just assign this new integer object to a pointer of type integer with a capital I, then never call delete, the destructor for my object would never get called. But to show you that indeed this memory is getting deallocated, you can see that it did call the destructor for the integer object, and the reason for that is that the destructor for the auto pointer gets called when we hit the end of main. That in turn automatically calls the delete operator, or uses the delete operator to delete the integer object that we had originally created. And when you delete any object that was dynamically allocated, first its destructor gets called, then the object's memory is returned to the system. So here we're just showing you the very basics of working with an auto pointer. Another thing that's interesting about auto pointers is that when you copy an auto pointer, it transfers ownership of the dynamic memory from the auto pointer that originally had it to the auto pointer that you're assigning it to. So if I assign one auto pointer to another auto pointer, the one on the right side of the assignment no longer owns the memory, and the one on the left side of the assignment is now responsible for it. And similarly, if I pass an auto pointer into a function or return it from a function by value, during the copying of the auto pointer, it transfers ownership along to the called function in the case of passing by value, or returns ownership back to the caller in the case of returning by value.